Okay. Hi. Am I audible? Am I audible? Can you hear me? Okay. I hope you can see the screen also. Right? The screen is also visible to you. We are at choosing granularity slide. Okay. Fine. Fine. Now, let us begin with today's class. Um, Look, after a few minutes, that is saying something. Wait, hold on. Hmm. So, in our last class, the combined one with bx and by, we had the single valued attributes. Here we talked about the various forms of frame representation for single valued attributes at that class, right? So today we're starting out from here. Uh, Even before we talk about this, there are certain simple things I'd like to uh, remind you about our previous lectures, right? Those things are, you may keep looking towards the slide also, or it's better if you listen to me precisely. Let's say initially when we were talking about the semantic nets and the frame representation. So in case of frame representation, it comprised of many number of slots, and each slot carried different values, which we used to call as the attributes, which the slots used to have various values. We used to call it as the attributes, right? So let's see if we are talking about uh, a generalization or a specialization example, then from the top down approach or from the bottom up approach. In both the cases, for a simple example, let's say the employee hierarchy in any organization. So I can say that the managers, then starting from the base, there are certain employees who are workers, then there are skilled workers, then there are managers, then there are executives, and at the top, after combining all of them, we just call them as the employees, right? So a bottom-up architecture show a kind of a pyramidal structure as we are moving from the base towards the top. That means the more we go higher up, we do have large number of high level facts, right? Now you can look towards the slides. We do have a large number of high level facts, and the more we go down, we do have the low level primitives, right? That means we are having more and more information as we go down the structure. Please put off your mic. Please put off your mic. ठीक है तो as we आज थोड़ा सा आपको बहुत आज से थोड़ा सा क्विकली देखना है. Around 33 people are here, so I'd like to say some of you see you are joining a little late. It doesn't matter at all. uh, we have to finish our courses by 23rd, right? 23rd of this month. So we have got around 8 days of time left. In 8 days, if I even consider the Sunday also, so we'll be having 4 classes on your part, 4 to 5 classes on your part. So please, you have cooperated with me before I even submitted my PhD, and now also you got to cooperate with me for a little more time until 23rd. What you got to do is, if I am extending this lecture for another a half an hour, 45 minutes, or 1 hour, you got to abide by that, please, for God's sake. I'll just be giving you the ideas that what are the things you should study and what are the things you can leave. So I'll be giving you brief ideas of almost everything, and I'll be trying my best to exhaustively explain some of the very important stuff, right? So please hold on with that. I'll be definitely giving you a break in between this. So let's move on with this now. We are having the low level primitives and may require and with the more low level primitives we do have, the higher will be the storage cost for those kind of information set, right? And the more will be the complexities for the frame, because the joining of the frame with another frame starts up from the slot level, right? So assigning any other frames rh slot will become much more complex if we are having higher number of level primitives. So this whole idea gives us a kind of an impression that we should choose the level of the granularity with certain amount of what should I say, a bottleneck, right? So what should be the level of the fineness or the granular structure that should be there? For that, we do have a very good example out here, like John Spotted Sue, right? John Spotted Sue is one of the assertions that has been given to you. Now, this thing could be represented in the form of like you can see it here. Spotted John spotted Sue, right? This is an agent, and here's the object. We do have the simple predicate structure that you can see here. I'll not be repeating all the things we have gone through in our lecture classes or during our physical lecture classes back at GUED, right? So such representation will definitely give you a very good advantage of answering some of the questions like who spotted Sue, right? So the moment we are using the actual part of the predicate, that means spotted, who spotted Sue, then obviously the answer will immediately come up as John, right? But if this question is changed by another question like did John see Sue, the system or the information extractor will not be able to extract this kind of information, even though the fact is that C and spotted both are exactly the same thing. But since the definition of C has not been properly cited in my granular structure of information representation or knowledge representation, hence I'm not able to fetch those kind of informations out here, right? Now, given this fact, if I add up one more fact with this, like X spotted Y, that implies X saw Y. The moment I'm putting up a more finer granular structure to this information representation or knowledge representation, then it will be able to answer questions like did John see Sue, right? Let's move on. We'll not be running fast, but still we'll be running a bit steadily today, from today onwards, in fact. Now comes the set of objects. How are you going to remember this thing during your examination? What is this set of objects? Let's say, yesterday I was giving an example to the BY guys. Like, the example was, let's say there's a community, and in that community I'm talking about the people residing back in the city of New York does have higher amount of money as compared to people residing in Kenya, right? So what am I doing? Is there something very specific about it? If I say Mr. X of New York is having higher money than Mr. A of Kenya, then this kind of comparison will take a lot of information to be rendered. Like I'm comparing one to one. Instead of that, if I pick up a set of objects or a class of individuals, and if I assign that quality to that class of individual, my complexity reduces to a considerable extent, right? So these kind of assertions can be seen out here. Like there are more ships than people in Australia. It's not talking about a particular ship, right? It's talking about the whole flock or the whole club of ship, right? They are compared with the people those who are residing in a country called Australia. The English speakers can be found all over the world. A more specified example to this is out here. Like, see, if the property is true for all or most of the elements of a set, then it is more efficient to associate it once with the set. This is what I have said a few seconds back, rather than to associate it explicitly with every element of that particular set. A very good example for this is given out here. There's a small predicate called the elephants are large, right? So what are the two inferences that we can draw? The set of elephant is large, right? A set of elephant is large. I'm talking about uh, a set of elephant that is present in front of me is large, or even I can talk about anything that has got the name of an elephant is supposedly large. Like anything that is an elephant is obviously a large. These kind of assignment of sets gives us an advantage, obviously, but there are certain conditions when or certain situations when these things fail. Like there may be a baby elephant whose size is not larger than that of a small cup, right? So under those cases, these things sometimes fail. These things are not of much importance. I have to admit, guys. Now, finding the right structure. This part you're gonna read of your own. It is nothing like simple structure information about how we do it. The very small thing. You can even skip this part also. There's nothing out here. Let's move. Please put up your now, knowledge representation is in predicate logic. They're again talking about the same old stuff. So we are just keeping it off. Now here's something important. Logic is concerned about three basic things: the syntax, that means the symbols. We even talk about the semantics, that means the actual meaning, and then we talk about the inference. Please, if you want to ask something, Chopra, Shivyansh Chopra, Shivesh Chopra, Shivyansh Chopra, you can ask something if you're feeling like asking, but don't. So these are inference rules out here, right? So you got to remember that in case of logic, you have the syntax, semantic, and the inference procedure that you're supposed to know, right? Now, we do have logic as a knowledge representation language. They hold certain kind of things like, wait, every time I have to add with these people. Something very painful. Well, what are the things that are required out here? Like they must be expressive enough, they must be efficient enough in reasoning, they must be expressive enough in representation. These are some of the things you need to remember. Known all these things, logics can be of different type. I have talked about these things many times, right? Well, this is what you should know. While building a logic-based representation, the user defines a set of primitives, that means the symbols, and their associated semantics with them, right? The logic defines the ways of putting symbols together so that the user can define a legal sentence. What are these legal sentences? That in the languages that represent true facts, that means they are tautologies. They are basically tautologies. That means they hold true for all occasions. That means they hold true for all occasions. Now, logic defines the way of inferring new sentences. That means you are inferring new information from the existing ones. We do have sentences either being true or false, but they can never be both. We call them as the propositions. You have known all these things. I'll not be going through all this part. Come up here. Now, let's say in our typical PL, we do have certain assertions of the facts that are true, like or false, like the sky is blue, the snow is cold, and we do have an multiplication of 12 plus 12 is 144. Right? These are simple sentences. They can be true, they can be false, right? Then the truth value is true, and if the proposition is false, then the truth value is obviously a false statement, right? Now here are certain examples, not mandatorily as in how they are supposed to go with their truth value or their propositional value, but still we are going through some of the examples of it. Like the grass is green. If it is seen to be green, obviously they are, so the truth value is true, and hence the proposition is yes. Now we do have something like 2 plus 5 is 5. It is obviously a wrong statement. That means not wrong, a false one. That means its truth value is false, and obviously this assertion that has been given is false, and hence the proposition that has been given is a yes, right? Now what we do have is close the door. That means the truth value has not been given. That means whether it is closed or not, no one knows. So the proposition is like a no. So this is how we are having a few more examples out here. We'll just go through them. We simply talked about proposition is the fundamental to all logic, and they do have proposition calculus. These are all the things we have gone through. Now, the statement, variables, and symbols that are involved in the truth table representation of propositional logic. This is something very important from my point of view as far as I understand the subject. So the statements are simple statements or sentences, right? They consist of lowercase letters like P, Q, and R. They are symbols. They are represented as symbols. They can be there can be sentences that are not just simple ones. They can be large, compound, or complex statements by use of certain conjunctions between them, right, or connectives between them. Now the connectives or the operators. Now here you have to pay a little bit of attention. I'm running a little fast today, a little fast, right? So, if I'm talking about the connectives of the operators, just a moment, let me put on the fan. Hey, can you hear me? Am I audible? Hello? Am I audible? What you? You people are BY, right? हाँ आप लोग BY हो ना? Yes, you people are BY. I called BY today, right? Can you hear me? Because I put on the fan. It should not disturb the way you are listening to me. I'm clearly audible, na? Okay, okay, fine, fine. It's okay. It's okay. Okay. Now in front of you, we do have the basic connectives also. Now by using these kind of connectives, like as you can see here, and you can create a formula which can be a complex or a compound one, like the one that is in front of you. Now, connectives and symbols in the decreasing order of their priority. That means this has got the higher priority and this has got the lower priority, the lowest priority that you can have. Now, let us see what are the things that we can see here. In assertion, we are talking about P has been asserted. That means something has been said, right? Something that has been said for P. So, P is true. If I'm asserting something, that means I'm asserting P, then P is supposedly true, right? Then P is supposedly true. If I'm talking about, if I'm talking about the negation, then I'm putting up a small negation symbol in front of P, and I'm saying it's a not of P. That means P is false, right? So I'm having the assertion, I'm having the negation. I'll be having the conjunction part of it. So P and Q. That means both P and Q are to be true, right? If I'm talking about P and Q, that means I'm talking about both P and Q to be true. If I'm talking about the disjunction part out here, then I'm talking about P or Q. Sometimes you're gonna see this symbol also. So this is an or part. So either P is true or Q is true or both are true, right? So either P is true, then also it will hold true. If Q is true, then also it will hold true. Or if both are true, then also it will hold true. Now we do have the implication. That means P implies Q. If there is something, then there is an if there is an antecedent, then there will be a consequent part of it. If there is an antecedent, there will be a consequent part of it. If I do have an hypothesis, if there is an hypothesis, there will be a conclusion of it. So reading it in this manner, I'll be having if P is true, then Q is true. That means P implies Q. So the moment we are having P to be true, I have to check for the conditions where the Q is true. But if the P is false, if the Q is false while P is true, then this implication will be in an overall manner will hold a false value. I'll be talking about all these things in the next example. Now we do have the equivalence. That means double-sided implication. That means it is somewhat like equal to. P and Q are either both true or both false. So the moment I do have a equivalence operator between them or a connective between them, then either P and Q will be both true or both false. If they are both true, then the fact is true. If they are both false, then also the fact is true. But if one is true and one is false, then you cannot hold this value, right? Dear students, I'm just requesting you, kindly try to be there in the lectures. I have to submit the screenshots, right? I have to submit the screenshots. Reason being, there should be a way out of making out distinction between the students. Obviously, the grades will be made in these testing times, right? You will be evaluated. There must be certain parameters where a faculty can evaluate you. So there might be situations when people will be asking for your attendance. So I still request you that even at the mid of this lecture also, if somebody wants to join up, please ask them to come up, because at least you should give me a chance to do the best that I can do for you, right? You have seen me in your T1 examinations, so please in these testing times at least be here. I am putting up my effort. आपको सुनना है सुनो, नहीं सुनना at least be here. Plug in your earphones, keep listening. This thing will help you out, trust me, right? So now we do have the equivalence operator. Now a very simple truth table we'll be checking out, like P is either true or false. So negation of P is either true or also either false. Likewise, P or Q is either true or false, and so on. For all the true cases, I'll be using a 1. For all the false cases, I'll be using a lower value of 0. That means for T, it will be high, and for false, that means F, it will be low. That means 0. So T is true and F is false. I do have the truth table defining the basic connectives, right? It will be very easier for you to understand the first row and in understanding the last row. So I do have P here. Let's check out all these things one by one. We'll be solving two examples as we have done yesterday for the BX batch, right? So I do have a P value here that is true. I do have a Q value here that is true. So the opposite of P, that means negation of P is false, and the negation of Q is again a false, because P and Q holds a true value. If I am taking up the connective, that means an AND operation of P and Q, where P and Q are both true, then P and Q will be true, obviously. If P or Q is there and my P is true and my Q is true, then my P or Q will definitely be a true. Now I do have an assignment operator. That means P implies Q. P implies Q. Hold on. Again, a few are waiting in the lobby. So I do have P implies Q, that is true. I do have an equivalence operator out here. That means is P and Q both are true or both are false? Obviously both are true. That's why P implies, that means P equivalence Q is also true. Now Q implies P. That means P is true. If Q is true, P is true. So in this case, this is true. Now I am going here. Since this is synonymous to my first row, if P is false, then Q is false. That means the reverse of it. That means the negation of a false for Q is true. For P is true. For Q is it is true. P or Q it is false because both are false. Hence P and Q is false. P or Q is also false because both are false out here. Now P implies Q holds a true value. P implies Q holds a true value here, because in both these cases, if P is true, Q is true. That means if P is false is true, that means this is also true. If P is true for this particular value, Q is also true. So that's why it is true out here. The equivalence, that means if P is false and Q is false, or P is true, Q is true, then it is true in all the cases. The reverse of it will also hold true, since P and Q holds the same value of false. Now the problem arises when you are here. So we are having two things out here, the P's value being true here and the Q's value is false in the second row. If this is so, the reverse of true for P is false, the reverse of Q for false being true, so this thing becomes just the opposite of the first two. So this is the, now if I'm going for the P or Q in this part, P and Q in this part, then it is true and false. Obviously it will be a false one. If it is P or Q, then it will be true, since I do have one true out here. Now there is one more thing. P, let us finish this one first. P equivalence Q will be a false, because if P is true, Q has to be true, or P is false, Q has to be false. So this is false. Now the problem arises here, 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 and here. Okay? So what am I going to do here is, I do have, let's say here, P implies Q, right? So if P is true, Q has to be true. If P is true, Q has to be true. If P is true, Q has to be true. So it is a true here. If P is true, Q has to be true. It is false, hence it is false here. So if P's value is false, that means P is not true. I am going to forget about these two things. So automatically this thing becomes a true. The same thing is applicable out here in case of Q implies P. In this case, if Q is true, then P has to be true. So if Q is true, P is true, that means it is true. If Q is false, P is true, it is true. If Q is true and P is false, it has to be false. So this is the only case under which it will be false. And in the second one, I'm not concerned about Q being false. So it automatically becomes a true. So in a way, I just wanted to draw your attention towards this column. I want to draw your attention towards this column, and remaining parts is very easy for you to understand, right? So now what we are going to do here is, I'll be moving on, and after some time we'll be solving two problems, right? After a few more minutes, we'll be solving two problems. There are a few terms that you need to know. Tautologies. Tautologies are what? Now, irrespective of the values of P, if my predicate or a proposition is true for all values of P, I call it as a tautologies. If they are false, that means my proposition is false for any value of P. Here I am having a positive P, a negative P, and I am having an OR. So in this case, whatever may be my value of P, it will always be a true, right? It will always be true. So it will be called as a tautology, right? I may have a contradictions. That means irrespective of the value of P here and negative P, since I am having a connective as an AND, so it will be always false. So these kind of propositions are called as the contradictions. I do have contingencies also, like backup. That means they can have variable values. So I can have P or Q as a contingency out here. Now we have already gone through the antecedent and the consequent part. So if clause is my antecedent part and the then clause is my consequent part. So I am having an antecedent part, I am having a consequent part. We have gone through all these things previously in details. There is something also we call it as the argument, right? What is this argument part? How would you enhance an argument? To enhance an argument, you need to have two things: the premise and the conclusion. What is premise? Premise is something that under which cases the grounds are given or the reasons are provided for asserting certain things as an evidence. I mean, these grounds are given as an evidence to assert something or to prove something. And conclusion is, from the previously held facts, I am concluding something. Or if I am not having the facts, I'll be demanding for those facts, right? So an argument basically comprises of that bird is a crow, therefore it is black. So I do have a premise, that means birds which are of the category of crow, or they belong to the species of crow, they are generally of black color. So from your examination point of view, you need to remember under arguments, you need to understand what is premise and what is conclusion. You have to remember a few things also, right? Now, an argument is valid. Now, checking for the validation of the argument, if and only It is valid if and only if it is a tautology, right? If and only if it is a tautology, we call it as a valid. If it is a constant, if and only if there is no contradiction, that means either they are true or they are false, but they are not both, and they are logically equivalent. That means I do have a double implication or a kind of equivalent statement, and it also is a tautology. So if it is a tautology and I do have an equivalence, I call it as logically equivalent. If there are no contradictions at all, I call it as a consistent, and if they are all tautology, I call it as a valid. So these are some of the categories, right? I'm not going to talk about all these things. They're talking about again the predicate part of it, right? We have gone through all these in our examples in the class itself. The same things, car is blue, this, and this. You have known all these things. Judy runs. This is a simple predicate. No need to go through all these things. Yeah, here they're talking about the operators of disjunction and conjunction. The example is out here. You can see this thing, or you are having this part. So obviously for all the connectives and for all the operators that are involved here, this statement is a false one, right? Please, I'm running a little steadily, not fast, a little steadily, right? Now, predicate quantifiers, no need to talk about it. We have gone through it many number of times, right? The quantification statement, what is the statement? What is the declaration part of it, right? X is an element of a set A. Universal quantifier, we have talked about. Existential quantifier, we have talked about. Existential quantifiers, we have talked about. Then universe of discourse. Universe of discourse is very clearly, it can be seen here, like when we talk about natural numbers for all x and y, this thing is there. So there is no need to be more precise. That means for all x in n, we generally don't say, where n is nothing but what? The universe of discourse. We have gone through all these things in the class previously. Applying a universal quantifier for all. These are the simple examples of how we do it. We have already done all these things in our predicate logic very exhaustively. These are the simple examples of it. That is for all x, where x is a car, x has wheels, right? All these things are there. Existential quantifier, again the same thing, right? You have gone through all these things previously, exclusively in our predicate logic part. Okay. In our predicate logic part. Okay, fine. There is a formula part, that is formula building part. So for functions, I do have certain terms or symbols inside them, ranging from T1 to Tn. There are certain terms, we call them as the atomic formulas. So atomic formulas are generally well-formed. Atomic formulas are the simplest well-formed formulas. It is basically a fraction of the WFS, right? Now, when they are joined in multiple numbers, we call them as the compound formulas. And when we do have a properly written predicate part, we call them as the well-formed formulas or the WFFs, right? We call them as the WFFs. Now, here you can see the atomic formula is of the form T1 and T2. These are atomic formulas. These are simple predicate formulas. So if this is a formula, that means not A is a formula and A is a formula, then obviously this thing will be treated as a formula. A compound formula is nothing but when we do have multiple connectives in between them, right, or operators in between them, and it is a huge chunk of smaller atomic formulas. I call them as the compound formula. Here, how their how is an instance relationship is written in front of a simple proposition, that means Joe is a musician. Then under those cases, the instance of a class or a thing, we call it as a musician, and Joe is an instance and musician is a class. This is a very simple example. You can see it here too, right? Now we do have yes, from here and solving a few more examples. It's almost 20. You do one thing. You take up a break for 5 minutes, right? 5 to 10 minutes. We'll again join after that. right? And before, wait, don't go, don't leave the meeting. Shwesh, are you there? Shwesh, are you there?
Yes, sir. Yes, sir.
प्लीज अभी अभी का एक अटेंडेंस आप ले लो, इसके स्क्रीनशॉट्स अभी के ले लो. There are around 47
ले लिया
participants right now. इनका एक बार ले लो and please join me. अभी don't go before he takes up all the screenshots, and after that there are 47 present right now. And join me after he takes up. Join me at around it is 5:20. Join me at around 5:25 or 30. Again, we'll proceed for another 45 minutes, and we'll be getting two attendance for this, right? Suresh, you have taken all the screenshots? Suresh, you have taken? All the attendance is done? Okay, fine. We are meeting in the next 10 minutes again, huh? You can leave the meeting. Thank you.